Hello everyone and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically.
What am I doing?
So in this video, we are going to take a look at a board that is again Rockchip based, but there are a lot of custom important things that I need to highlight in this board. It's actually consisted of two parts. So one is the AIM module, which is AI module. It is from ArmSoM. So we have looked at other products from ArmSoM before in this channel. And this one, we are going to take a look at ArmSoM AIM7, which is RK3588 based. So basically quad ARM Cortex A76, quad ARM Cortex A55, and also the usual ARM Mali G610. It comes with 8GB memory or up to 32GB memory. They're claiming that it can do 8K at 30 FPS, H265, H264 encoding. So decoding, it can do 8K at 60 FPS, and it supports H265, VP9, AVS2, all that stuff. For 8K at 30 FPS, it can also do AVC, MVC, AV1, and other encoding and decoding codecs. So let me show you first what I'm talking about. So it comes, as I said, in two parts. One is AIM7. So one of the most important things about this is compatible with Jetson Nano. If you have some carrier boards or Jetson Nano itself, right, that comes with the development kit, this is compatible with that. So if you have, for instance, I looked at it during Python in our channel. So their carrier board was compatible with Jetson Nano. So it is going to be compatible with this as well. So it's RK3588, as you can see here. So this is the board and nothing on the back. There's just the storage and the RAM. And also let's take a look at its carrier. That's also from ArmSoM. Okay, so if we take this out, yeah, it's beautiful. So this one, all you have to do is just like installing a RAM, right? Like SODIMM RAMs, like laptop, for instance. So that's all you have to do. Just push it in there, and alternatively, you can push in the Jetson Nano, or take just the AIM module, use it in some other board that supports Jetson Nano. So it's very versatile. You can use it for a lot of things. It's very nice. So I'm going to take a look at everything as much as I can on this board. There is, yeah, absolutely nothing else. Yep, the boxes are empty. So before starting the video, I already prepared. So one is Armbian, one is Ubuntu Rockchip, and then there is also a Debian version. So if you want, there is also there. It's on their repo website and documentation website. Let's walk through the ports on this. So if we want to go through the IO on this board, basically this is the PoE header. This is the 40 pin header. There is a power button right over here, a USB Type-C over here, a Gigabyte Ethernet right over there, and 1, 2, 3, 4, all four are USB 3.0. And there is the display port and HDMI, and there is the barrel jack DC for supplying the power to the board. This is the CSI, so camera and the camera, so 0 and 1, camera and camera CSIs. On the back we have the display ones. Looks like this is the DSI, and these are CSI camera and camera. Yeah, so display ones are on the back, but I think these are maybe not the camera, but the display ones look proprietary, but I don't know. Yeah, this is AIMIO board V1.1. SD card goes right there, as you can see. There is also, before installing this, there was one thing underneath I forgot to show you. There is also M.2 E key over here. So if you want, you can install, I guess, you know, Wi-Fi card or something like that right over there. Yeah, and there is a fan header right there. So there are also a bunch of connectors right over here. This is like a LED power. So yeah, these are for like UART and ground connection and some other controlling LED and power and other stuff. So you have 4 T-pin over here, bunch of pins over there. I think those are related to this, but I might be wrong. So it is actually not on sale yet, so you can't really go out and check out. So they, ArmSoM people, their team sent this to me. They are launching a campaign on crowd supply. So basically you have to buy it from crowd supply and they will ship it. They were saying end of March ish, so they were saying within the Q1 2025. So that's the goal. So what I'm gonna do, at 12 volts in, I have a bunch laying around. I'm gonna grab a power supply, put power in there. Let's see how things are in Ubuntu. Okay, and I will connect the display and all that stuff. So let me get things going and we'll take a look look at the operating system, do some benchmarks, run some LLM models. Let's see if they're calling it AIM board. So for AI, let's see how it does. And I need to put a heat sink on this bad boy. I forgot to say bad boy in this video, so I just remembered. Let me prepare everything. I will be right back. I set everything up, even put some, I chose random pins, which we are going to do a GPIO test very quickly, just the voltage. Yeah, let's go. So first things first, I will do a new fetch. As you can see, this is ArmSoM AIM7. And by the way, I found this is not exact fit for this board, but I just put it in there so you can see that the temperatures are cool. And I did one quick suspension stuff, so that's why the max temp is the high, but overall it's good. 35, 36 idling. As you can see, it's a Debian 11. This is what they provided, and ArmSoM RK3588 AIM7 board, and you see the rest of the stuff. Okay, so very quickly I'm going to type out the command for stressng. All right, so let's take a look at it. And yep, as expected, almost every single RK3588 when I'm testing it, I am getting 1233 for 30 seconds run of the stressng's matrix prot test. So that's basically 40 ops per second. All right, so that being said, let me also very quickly test the iCurve3 and confirm the Ethernet speeds. And yes, as expected, that's exactly what the gigabit Ethernet is going to look like. That's also fine. Yeah, so I am going to show you guys one thing that I got from them. This is the LLM demo distilled version of DeepSeek R1 for RK3588 chips. It is used by other vendors as well for showcasing LLM capabilities of the RK3588 and other ROC chip-based SoCs. So, unfortunately, it's not really great in terms of numbers. It doesn't have the like dash verbose in Ollama. You will just have to kind of see the performance. Okay, let me show you what I'm talking about. So Ollama, LLM demo, and DeepSeek. Okay, there you go. We have the model loaded. Basically, as you can see, CPU usage is 100%. So what is your name? Okay, so you can see the speed. It's kind of very fast. Okay, let's ask a very simple question. Write a C++ function that would accept two integer parameters, add them, and return your value. Just something like that. I just want to see. You can see this is real time. It's not fast forwarded. I just want you to see the performance and the speed. So what you see on the screen is exactly as is. I'm not speeding anything up for now. It's fast. So I don't know how many tokens per second is this, but you can tell it's fast. And look at the CPU usage and the temperatures. Yeah, as you can see, it's doing great. Honestly, for such a small board, it's doing great. Yeah, this is 5 volt 2 amps, by the way. Okay, so that was pretty much it, and we got the results. Okay, that's what I wanted to show you. Another thing that I can show you is basically a YouTube video playback on the Chrome that they are shipping with. I did not install any of this. Okay, so I set it to 4K resolution, and we are playing a 4K video. Let's go full screen. Okay, as you can see, 4K video playback is smooth, and it's sometimes, see, it stopped dropping frames, as you can see. Yeah, it stopped dropping frames. So it is very smooth. It's 60 FPS, 4K video, and it stopped dropping frames. Barely 1 frames every here and there. It's okay for video playback stuff, but obviously that's not the purpose for this. This is AIM7. It's more for LLM and AI applications and stuff, but yeah, I just wanted to show you guys that it works as well. Another thing that you might want to try is the GPIO pins. So let me show you their documentation that was here. So you have to go to AIM board, which is the carrier board, and what I chose was, I saw that there is a ground pin here in 25, and right next to it is this pin. So that's literally what I did. 26 and 25, I placed the wires in there, and I'm gonna turn on the multimeter so you can see right now it's 0 0 right now. Okay, so now let's go back to the code, I mean the console. So what I'm gonna do is echo 45 to sys class GPIO export, and then echo out to sys class GPIO 45 direction, and echo to the value of 1. All right, let's take a look at it. 1 2 3, there you have it. And if we go to 0, goes back to 0. Easy. So I just wanted to show you guys that the GPIO stuff also works. LLM works, and I showed you guys StressNG. I showed you guys the 4K video playback, and so far so good. And you can see the temperatures are always cool in the manageable range. It's doing fine, that thing that I put in there. So I don't really have anything to complain about. When you get this board, you are going to get an RK3588 that's on this carrier board, 40 pin GPIO, everything is working in there. You will have HDMI and DisplayPort output, and you saw the demo for DeepSeek R1, and it was relatively fast, and it can solve a lot of questions that you can throw at it. It will give you some good code and help you with a lot of tasks. So if you want to do some sort of event, maybe, I don't know, home automation, go crazy. You can do, you know, sending commands to it with the AI, getting response back. You can use their outputs for the camera and also for the screen to make it a small board with a screen on top, 3D print a case, and use it. I mean, I don't find any issues, any problems so far. Everything is working fine, no complication. Documentation is great. As you can see, there are 2 pages here. So one is the IO carrier board page documentation, which is the board, IO board, and then there is the separate documentation for the card, that AIM7 that you put into this carrier. Here you will be able to see a lot of documentation, explanation, even like schematics and everything is published as well right here, and all the way down I saw that they have also schematics published somewhere. So AIM7 pin function table and package, you will see all sorts of schematics and other stuff in there. And the ArmSoM and the other ones are going to be apparently made some changes. So those ArmSoM and the Ubuntu images gotta release a new one, and then it will work. If something apparently gotta change in U-boot code or something, so they're gonna change. But overall, the Debian 11 that they're shipping it with, obviously, as you can see, it's working. But yeah, the only thing I had to do, to be honest, I had to do a dpkg reconfigure locale. Okay, so you have to just run that command. So let me show you one more time. dpkg reconfigure locales. Okay, you run that, and by default you have to go all the way down this dhcn. That would be the default here for the Chinese. You have to unselect it and find the language obviously you like, but I chose the ENUS and enabled it, and that's pretty much it. One reboot and interface and everything turns English. That was it. I didn't do anything else. Otherwise, GPIO works and everything else I tried, the LLM demo as well, and the 4K playback. So I don't know what else you guys want me to show you. There are not much for like documentation on specifically for this to like overclock or something like that, or underclock or anything. You know, it's RK35, and there are some non-Debian ones. Like in ArmSoM, you will have a lot of settings in there. I know ArmSoM, there are some overclocking apps and options in there. Not in here, but you know, it doesn't matter. You can figure out, or just hopefully ArmSoM will come and release their version sooner and you will be able to use that. Okay, one thing I just remembered that I didn't show you the power consumption. So as you can see right now, it's 1.5 watts. Okay, I'm idle in Debian. Okay, when you're doing nothing, it's using 5 volts, 0.3 amp, meaning 1.5 watts. Okay, so now watch me. I'm gonna start the LK LLM demo for RK3588. As you can see, it went up to 2.5 watts with 5 volt. That's it, 0.2 watts right now. So you're running DeepSeek R1, this model, for 2 watts. Okay, so if I type, what is your name? It goes up to 1.1 amps, 6 watts, 5 watts, 6. Okay, it stopped. So let me give it a longer command. Hold on a second. All right, so that's gonna run for a while. So let's take a look at it. So it's writing a command, and 5.6, 5 watts, 6 watts, 6 watts. So I was going to say 5.5 watts average. Yeah, 1 amp, okay? 5 volt, 1 amp, 1.1, 1.2 amps. So you see that's the range, okay? You can keep an eye on it. It goes up and down, up and down. So right now it's 6.1, 6 watts. So 5 watts, 6 watt, it goes up and down. So there you have it. It's still running. The model is still printing out code, as you can see on the screen, and this is the power consumption, as you can see. So you guys have it here. You keep that in mind. That's how much power it needs to do this fast. As you can see, it's really fast on the screen. I don't know how many tokens per second that equates to, but that's what it is. So yeah, I'm gonna stop that. So you got it. So 5 to 6 watts, and you will have a DeepSeek R1, this model, working perfectly in your AIM7 board. And the temperatures are are always cool. That's one thing I want to show you. Give me a couple of seconds. Okay, so here's one last test that I want to do. Although they claim that these two are compatible, I just want to see that. So first, I just want to plug this one in. This is the Jetson Nano Super. So that's the latest version. I just want to show you that this is booting and there is some Ubuntu image on it, and then to power it off. This is something else. I just want to see and show you that it is work. There you go. There is some Ubuntu. I'm not gonna wait. Yeah, there is Ubuntu. Okay, so you saw that. Now time for testing compatibility. So first, you know, I don't know, maybe something will burn up. The things I do for the social media, you know, for a couple of likes. I'm risking my life over here. So anyway, jokes aside, I just want to see if anything blows up so we all see that together. Yay! So now I placed AIM7 on Jetson Nano carrier board. 1, 2, 3. No fireworks. Anything hot? Not really. But also I'm not seeing anything on the screen. So still nothing. Maybe I have to press the button in here. I'm gonna press that once. Nope. Although the pins are compatible, it doesn't mean that you can plug AIM7 into this carrier board. So while we are risking lives here, let's do it all the way. Now I'm gonna do the other way. I'm going to put this into this AIM7 carrier board. It's actually perfect fit. I get that. If something happens, you all get to see it at least and laugh at me. 1, 2, 3. Okay, hold on. Since nothing happened, I want to connect a bunch of stuff. Okay, so let me connect HDMI and a mouse and a keyboard. No need for Ethernet. Okay, I'm also recording the screen. If anything comes on the screen, we'll see it. Okay, fan not spinning because it's not connected. That's okay. Let's see if anything shows up on the screen. Even if I see that boot screen, I'm fine with that. So far, nothing. Also, no fireworks. Oh, look at that. Okay, so I'm not gonna do a lot of testing this. Okay, it's already hot. Okay, so yeah, it's getting hot, but I mean, it's working ish, you know? Yes. Okay, so there you have it. All right, so why? I don't know why, but this is the result. No fireworks, okay? And pins are compatible. And if I put AIM7 in the Jetson Nano Super kit, it doesn't work. But if I put the Jetson Nano in their carrier board, it works. There you have it. So I tested that as well for you. So hopefully you guys enjoyed this video. Give a thumbs up if you liked it. And please let me know if you have any questions. I will try to answer them. And yeah, so this is basically the board this whole video was about. So this is the carrier board, which also accepts Jetson Nano. You can put this in there. And this is their version of the card, which uses RK3588. You can plug this in there. And as you saw, the scores and everything and the power consumption. Okay, thanks for watching, and I will see you in the next video. Bye for now.